Hello, this video is focusing on integration of logarithmic and exponential function. Before we start the integration, let's check the differentiation formulas from the previous section. That means we remember derivative of a to the x is a to the x times ln of a. That's the first one. Derivative of e to the x is just e to the x, because even if we will multiply by ln of e is 1. We don't have to do it. Derivative of ln of x, it's 1 over x. This works for all of the numbers except 0, of course. I mean, I can even make ln of the absolute value of x is also 1 over x. And the derivative of the logarithmic function based a of x is also 1 over x times ln of a. That means now what we will do, we will try to reverse these formulas. Let's start with formula that was introduced in Calculus 1 and is the integration of the power function. That's when we remember x to the power of n, integral of x to the power of n dx is equal to x to the power of n plus 1 over n plus 1 plus the constant of integration. This formula works for all of the numbers. N could be any real number except positive 1. Negative 1. This is my typo, because if I will put negative 1 plus 1, we're getting 0. We can't divide by 0. Okay, that means this one actually should be negative 1. Let me correct this. I can use different color. Oh, negative 1. Okay, but now we can see the missing part, x to the negative 1, which is integral of 1 over x, is equal to ln of x. As we can see, based on the differentiation formulas, we know what is the integral of x to the integral of 1 over x. Okay, that means this will be our new formula, the missing part from Calculus 1. Okay, that means now let's look at the other formulas. The first one is, that's what we just talked about, integral of 1 over x dx is ln of absolute value of x plus the constant c. The second one is the same formula, but what we're doing, we're using the u substitution, or if you would like to look from differentiation perspective, the chain rule is involved. Because if I will have this function, I can let u to be f of x, and du, it's simply f prime of x dx. That we can see, this is part of the integrand, and my integral will be simply 1 over u du. Okay, and then integral of 1 over u du, of course, is ln of u plus the constant of integration, and u was the function from the denominator. And that's what we just had. But it's worth to remember that if we have a rational function and f of x is in the denominator and f prime is in the numerator, then the whole integral is simply ln of the function from the denominator. Right, we can see this is giving me this. Okay, and now the third formula, it's relatively easy. Integral of e to the x is just e to the x, and integral of the general exponential function a to the x is also a to the x, but we have to remember we are dividing by ln of a. Okay, that means that's our formulas, and let's use them. I have the first exercise, integral from 1 to 2 of 1 over x dx. That means since the function is positive, I have the function, and simply this means the area under the curve from 1 to 2. That's we can make the interpretation like that. And now let's get the answer. That we know right away the antiderivative ln of absolute value of x and from 1 to 2 because it's a definite integral. Let's substitute the upper limit, subtraction, substituting the lower limit. Ln of 2 and ln of 1 is 0. That means this is simply natural log of 2. Hopefully you remember from the previous section, this is like about 0.69, but we don't have to know it. The natural log of 2 is the good answer. Okay? Exercise number 2. Evaluate the limit 1 over 2x dx from 1 to 3. Okay, that means this is almost the same. What I would like to show you, I would like to show you that we can take constant 1/2 and put outside the integral. Because if the expression is not related to x, we can simply put outside. And now almost the same like exercise 1. Integral of 1 over x is ln of x from 1 to 3. Okay, 1/2. Let's substitute upper limit, substitute the lower limit. We don't have to put absolute value since the numbers are positive, but I just did ln of 3, and this is of course 0. That we do have 1/2 natural log of 3. We can rewrite like that. 1/2 could be I can possibly put this. We can put this 1/2 here, and then 1/2 means the square root. Exercise, that was number 2. Exercise number 3. Let's evaluate an integral ln of x over x dx from 1 to e. We don't really have to know how the function looks like, but I draw a function, and since is from 1 to e, function is positive, the same our integral will represent the area under the curve. Okay, we can actually see the answer is 1/2. Let's try to get it. Okay, this integral, I think we will use the integration by parts. The u substitution. I'm just thinking about the other techniques which will be introduced next week. No. So far, we only know one integration technique. U substitution. That means I will let u to be natural log of x. Du is derivative of ln of x is 1 over x dx. Okay, and we can see 1 over x dx, this is gonna be replaced with du. Okay, that means let's see what we have. And just ln of x was u. U dx, we can see dx over x is du. Okay. Integral of u du is just u squared over 2. But what we do have a new limits of integration. New limits. Integration. Okay, that means if x is 1, we can see x is 1, then I can compute u value, which will be ln of 1, which is actually 0. Okay, instead of 1, we have 0. If x is e, I can compute u value ln of e. Ln of e is 1. Okay, that's mean the new limits of integrations are from 0 to 1. And I was just using ln of x. Okay, that's mean now let's substitute 1 and 0, 1 squared over 2, and 0 squared over 2. Of course, we don't have to put 0. Simply 1/2. Okay, it matches to my answer. Okay, really nice integral, few important components. Okay, let's keep integrating. Okay, my next exercise, I have for you 3 integrals, and all of them will be based on this formula. That's mean one more time. Looking at the rational function and seeing a function in the denominator and its derivative on the top, we can say right away is ln of the function from the denominator. Of course, as I said on the previous slides, you can try the u substitution, Okay, but we can just simply remember this formula, just to be a little bit more efficient with the integration. Okay, that means now I can say derivative of x plus 1 is 1. That means I can just say ln of the denominator. Okay, derivative of 3x squared minus 1 is 6x. Nothing else like ln of the denominator. And derivative of tan x plus e to the x, derivative of tan x is secant square of x, derivative of e to the x is just e to the x. Works. Ln of the denominator. But please remember, we can say ln of the denominator if and only if we do have a derivative on the top. That means that's the derivative from the function of the denominator. Integral number 5. Okay, this one, I don't think we can use the u substitution, because if I will let u to be inner function, I have nothing to cancel out. Okay, that means I will simply expand this using a plus b squared, which is a squared plus 2ab plus b squared. Or you can FOIL. Yeah, this is the same like a plus b times another a plus b. And you will get this answer. Okay, that means let's expand this. E to the power of x and squared plus 2 times e to the x, e to the negative x, and e to the negative x squared. Everything dx. Okay. Let me put this as a formula, and I will just... Okay, and now let's integrate. E to the power of x and to the power of 2 is e to the 2x. E to the x times e to the negative x is just e to the power of 0, which is simply 1. And e to the negative x and squared is e to the negative 2x. Okay, one more time. E to the 2x plus 2 plus e to the negative. Okay, that's mean now an integral of e to the 2x is the same function, e to the 2x, times, not times 2, since this is antiderivative, times 1/2. That's mean the reciprocal of this coefficient. We may use the u substitution, but also we can just remember this property. Integral of 2 dx is just 2x, and integral of e to the negative 2x is e to the negative 2x times negative half. 1/2 e to the 2x plus 2x minus 1/2 e to the negative 2x. And I can nicely box the final answer. Okay. Integral of tangent of x. I don't think the u substitution will work. I mean, actually, maybe the u substitution will work. But what I have to do, I will rewrite this. Tangent of x is sine of x over cosine of x. Okay, and actually no, the u substitution works. I can let u to be cosine of x. Du is negative sine of x dx. I only see sine of x dx, that means I will multiply everything by negative. Sine of x dx is simply equals to negative du. Okay, and my integral is 1 over u negative du. I can put negative here. Okay, negative integral of 1 over u is ln of u plus the constant of integration. Now let's substitute back. U was cosine of x. Another thing what I can do, cosine of x, and I can apply this negative as a negative 1, as an exponent negative 1. And cosine of x to the negative 1, it's 1 over cosine. And we know that in 1 over cosine is simply secant of x. And I know some of the textbooks are simply giving you this integral. You may remember, you may kind of memorize, but this is the integral that we don't really have to memorize. Spending like maybe 2-3 minutes, we can get this integral. That means integral of tangent of x is natural log of secant of x. Or, actually, I also like this form, negative ln of cosine of x. Okay, another exercise, integral of x times e to the negative x squared. We can see right away that u substitution will work perfectly. The inner function negative x squared is perfect for the u substitution. Integral of u du, integral of, not the integral, derivative. Derivative of negative x squared is negative 2x dx. And I see x dx, that means I will divide by negative 2. X dx is negative half du. Okay, let's replace everything. Negative half du and integral of e to the power of u. Negative half integral of e to the u du is just e to the u plus the constant of integration. And instead of u, I can put back negative x squared. That's my final answer. Exercise number 8. Integral of 2e to the x times cosine of e to the x. That means, again, I do see product. I see one function and the second function. And the second function looks more complex, is compound function. That means always the first guess should be the inner function as a u. Okay, I'm just trying to re-explain the u substitution. Looking at two parts, two functions, we're focusing on the compound function and pulling out the inner. That should be always our first guess for u substitution. And let's see if this works. U is e to the x, derivative of u is du, derivative of e to the x just e to the x dx. And I believe I can erase this for now, and I can highlight e to the x dx. This is gonna be du. Okay, this part will be replaced with du. Okay, let's see. 2. I can put 2 outside. E to the x dx is simply du and cosine of the inner function e to the x, and that was u. Okay, that means we do have 2. Integral of cosine of u is just sine of u, because derivative of sine is cosine. Okay, what we need? We need new limits of integration. New limits of integration. Let's see, x was natural log of pi over 6. Then u will be e to the power of ln of pi over 6. And we remember the cancellation equations. E and ln could be cancelled out. That means this is just pi over 6. Pi over 6. Pi over 6. Okay? If x is ln of pi over 2, u is defined as a e to the power of ln of pi over 2, which e and ln is cancelled out. Pi over 2 is the new value. Pi over 2, pi over 2. Okay, new limits of integration. No? Let me do it a little bit nicer. Okay, that's me. Now let's see. Let's substitute pi over 2 and pi over 6. A little bit of unit circle. 2 sine of pi over 2 minus sine of pi over 6. Sine at 90, sine at pi over 2 is 1. Sine at pi over 6, which is 30 degrees, it's 1/2. Okay, 2 times half, it's simply 1. integral of x times e to the x squared. The same thing. We can see the inner function x squared works perfect for the u substitution. Du will be 2x dx. We have x dx, we don't have 2. That means I will solve this equation for x dx. X dx is simply 1/2 du. 1/2 du and then 2 to the power of u. Integral of 2 to the power of u du is 2 to the power of u over ln of 2. ln of the base plus the constant of integration. 2 to the u, 2 ln of 2. And the only thing that we can do is substitute back instead of u x squared. And I can leave it like that. Okay, that's the final answer. Okay, I also have this integral. I did squeeze it here. And we remember this one, I did solve a few slides before. E to the power of 5x, the integral is simply e to the power of 5x, but we have to multiply by the reciprocal of the coefficient of x. That means the most general formula, e to the power of nx, n is a constant, is simply e to the nx times 1 over n. Okay, let me just... Okay, and I think I have 2 more, 1 and 2. Okay. Integral number 10 from 1 over 16 to 64, and it's log base 2 of x to x. What I will do, I will simply, maybe I will put 2 outside for now. Log base 2 of x over x, and I will keep my limits for now. And now we can see also that the u substitution will work. U, I will say, is log base 2 of x. Derivative of log base 2 of x is 1 over x times ln of 2 in the denominator dx. And I can see dx over x. That means I will just multiply the whole equation by ln of 2 du, and dx over x will stay on the right hand side. That means this one is ln of 2 du. Let's rewrite the whole integral. 1/2 and then integral of u, because the log is u, and just ln of 2 du. I will put ln of 2 over 2 outside. U du. ln of 2 over 2. Integral of u du is just u squared over 2. But what we need? We need a limits of integration. New limits of integration. Okay, let's work. New limits. If x is 1 over 16, yes, that's my first limit, then u will be, I'm just using this, log base 2 of x. Log base 2 of 1 over 16. 2 to the power of what number to get 1 over 16? 2 to the power of 4 will give me 16. 2 to the power of negative 4 will give me 1 over 16. That means this one is negative 4. Negative 4. Okay, and if x is 64, u will be log base 2 of 64. That means 2 to the power of what number to get 64? 16 is 4, 32 is 5, and 6 will be 64. That means 6 is the upper limit. 6. Okay, let's try to substitute. And what we getting? ln of 2, maybe 2 and 2 I can combine together, and I have u squared, which is 6 squared, minus negative 4 squared. Okay, ln of 2 over 4 36 minus 16, because negative 4 squared is 16, positive 16, and that negative still stays. ln of 2 over 4 times 20, which is, we can cancel out 5 times ln of 2. 5 ln of 2. We can also apply that 5 as an exponent. ln of 32. 2 to the power of 5 is 32. Okay, really nice integral. And I do have one more, and hopefully you will master all of these integration skills. Okay, this looks like an exam type or the quiz type because it's multiple choice. Okay, evaluate an integral from 0 to pi sine of x over 2 minus cosine of x. Okay, that's mean what I actually see. I see that my function from the denominator has its derivative on the top. That means I can say right away ln of the denominator. Oh, actually, hang on, I need absolute value. But let's see, what I will do, I will try the u substitution for u. Okay, I will let the whole denominator to be u. 2 minus cosine of x. du is negative cosine of x derivative is just sine of x. Am I right? Because negative and negative will cancel out. Okay, that's mean now we can see, let me erase this, I can see that sine of x dx is simply du. Okay, I can erase this. That's mean what we have? We have 1 over u and sine of x dx. I can still loop this as du. Okay, integral of 1 over u is just ln of u. Okay. And maybe avoiding the new limits, I can just substitute back 2 minus cosine of x. I can also do this. That's we can say it's just ln of the function from the denominator. But the u substitution is behind. And since I did come back to my x variable, I don't have to find the new limits. I can use 0 and pi, and that's the x value. Okay, let's substitute and let's check. ln, I can start from the beginning, from the ln 2 minus cosine of pi minus ln 2 minus cosine at 0. Okay, cosine at pi is negative 1. Cosine at 0 is 1. 2 minus subtracting negative 1 is adding 1, it's 3. This one is ln of 1, and ln at 1 is 0. Okay, that means the final answer is just natural log of 3. Yes, we did find the correct answer. Okay, that means please go through all of these integrals, make sure that you know how to integrate them, make sure that you understand the concept, and of course